So far, we know that the virtualized deployment model was better than the traditional model because it was saving some resources on our CPU and processing power and also on the memory. But then this was not the ideal approach. So we had to find something new. And that's where we moved to the container mode of deployment. And what does this mean is we have the host application or the host hardware, host computer. So this is a big host computer that you see in the blue one. On that we had hardware. It was having its host operating system, and then we installed something called as container runtime. And here when I mean by container runtime, I'm talking about Docker. So Docker is something we installed. So we can download Docker from the for the Windows and Linux environment and install that Docker runtime on our computer. So we started installing that Docker runtime on our hardware. What this enables is once we install the Docker engine on our hardware, then it allows us to deploy application into small blocks called containers. So if you see these are small blocks called containers, and then this container will be like acting as a self-isolated capsule or a group which will have everything that is needed for it to self-sustain independently wherever we throw it. So if we throw it into a Windows-based operating system, doesn't matter. If we throw it into a Linux-based operating system, it doesn't matter. This container is going to run as an isolated package independently because it has everything that it needs to survive. It has its application, it has its libraries, it has the file system of its own, it has its CPU, it has its own memory processing space. So everything is available inside this container. Hence, the container doesn't need to worry what operating system or host it is running on. Similarly, we can have many containers deployed inside a one particular big host where a container runtime is running. But then these containers are not just your application straightforward. They are something called as Docker images running, and then running instance of those Docker images are called containers. So what we you do is traditionally we create our application. So let's say this is our application, and this can be written in any technology. Let's say Java Spring Boot or Node.js, Python or PHP, doesn't matter. So usually we were deploying this application directly onto servers. But now with the container mode, we don't do that. We convert this application into an image which we call as a Docker image. How do we do that? We with the help of some commands that we write in a Docker file. So we create a Docker file. Here we write some commands, and these commands knows how to convert this image in this particular application into a Docker image. Then we have a Docker image, and now this Docker image is getting pushed to a repository where it gets stored. And now a Docker runtime which we have installed on the server knows how to fetch this image from this repository, and then with the help of this image it can run containers. So it can run container 1, container 2 of the same application. It can run multiple instances of container of the same application using the same image. But this can also run containers of application 2. Let's say there's another application 2 which has its own Docker image. This Docker image, if can be also run here. So this can be, let's say, container 3. So container 3 is for this application. Container 1 and container 2 are for this application. So Docker runtime knows, if we give it the Docker image, it knows to convert them into a running instance which we are calling as container. So if we go back to our example, here we see there's one application and there are two applications running inside one container. And this container, it has everything that this application needs for them to run. Similarly, there are other containers which run. And this Docker runtime is doing the magic of making sure these containers are running smoothly independent of the operating system on which the host is running on. So they don't have to worry about it. So what I mean by that is if I take this Docker image and deploy it into a Windows-based operating system, I don't have to touch this application, neither I have to touch the Docker file. This is going to run exactly same if it was to supposed to run on a Linux-based operating system or where the Docker runtime is running. So this Docker runtime, this container runtime is making this Docker container run independent of the host operating system. So with this approach, what happened is it became very lightweight and cost effective, and it also can be now scaled up and down very easily, and the overall utilization of resources like CPU and memory reduced drastically because every container had its own share of the CPU and memory and file system. So the burden on the host operating system reduced drastically, and then if we had to run the same container in, we have to duplicate this 10,000 times. It was very easy to do that. And then if we have to reduce it to back to 10 container instances, we can also do that. So scaling up and scaling down also became very simple. So as a container has little bit of everything, so they can easily be deployed on any hardware and managed easily because they are decoupled from the underlying hardware. Hence, the container can be easily deployed on the local environment, on an on-premise infrastructure, on any other cloud environment like Google, Amazon, or Azure cloud. The container doesn't have to worry about where it is going to get deployed. So that was the decoupling that happened, and the efficient memory utilization happened with the introduction of container-based deployment. But then it also brought another problem. The problem was at any point of time there can be hundreds and thousands of containers running. There can be same application containers running. Let's say container 1, container 2, there are two instances running. Container 2, there is two instances. Container 3, only one instance is running. Similarly, consider each container having a one application. Let's say it is having Node.js application, this is having Spring Boot application, this is having Python application, doing different functionalities. Maybe this can also have a database running inside it as a container. So anything can run inside a container. So, but then these containers, they are running, and let's say there is a lot of traffic coming on. So container one instance needs to be scaled up to hundreds of container one. Similarly, when the traffic is gone, this should be reduced down to one container. What if the container one instance dies? Somebody has to come and bring this up again. Otherwise, the request to this container one will start failing. So this kind of complexity came up with this container based deployment approach. So there was also a problem of monitoring the health of each containers, the security of these containers, how will these containers talk to each other. So those kind of things came into picture with this new container deployment approach. So how did this problem was, I mean, how does the problem got solved automatically? So for answering that question, we have to go to the next lecture where we will see how this problem was solved very easily. Thank you.